Okay, so again, we are working right now in 10.1. Here is the exam 4 notes. So this is the top of the Unit 4 module. We're in the last module of the course. We're beginning the end of the course. Unit 4, there's exam 4 notes provided for you right at the top of module 4. So I encourage you to click on that, open that file, have that printed, or just have it open so you can refer to it. I'll be showing it as we work through the problem. This is Unit 4. We're going to start talking about 2 samples, correlation, fit, and independence, which probably doesn't mean a lot. Maybe 2 samples does, and you'll see as we go. All right, let's get back to it again. And look at the actual homework. All right, there it is. Here is 10.1, hypothesis test and confidence interval for a difference between 2 population proportions. Okay, what are we doing today? What are we doing in this section? What's different? Haven't we done everything? Well, what we want to do now is we want to talk about 2 populations, not just 1. We want to say, how do you compare 2 at the same time? That's what this is all about. That's what's new. That's what chapter 10 is all about. In fact, let me write that up here. Chapter 10 is all about 2 groups at the same time. So chapter 10 is all about 2 groups at the same time. Instead of just having 1 group, we have 2. So let's see this on the first question here. Are freshmen psychology majors just as likely to change their major before they graduate compared to freshman business majors? See how we're talking about 2 groups right away? We're talking about psychology majors and business majors. 2 groups. Psychology majors and business majors. That's what this whole chapter is going to be about. So the stuff in chapter 9, we just had 1 group at a time, right? They would give us maybe just the psychology majors, and they would say, hey, for these psychology majors, what's the what percentage of them change their major before they graduate? Is it more than 10% or less than 10%? You know, it'd be something like that. That was in chapter 9. But now in chapter 10, we want to compare 2 groups at the same time. So are psychology majors or business majors more likely, or are psychology just as likely is really what they said, right? Just as likely. Okay, let's read on. 346 of the 629 freshman psych majors from a recent study changed their major before they graduated. That's a lot. It's like more than half, I think. And 433 of 760 freshman business majors changed their major. That's more than half as well. It's a lot of major changing. I guess I changed my major too. Before they graduated, I was engineering and changed to math. What can be concluded at the alpha 0.10 level of significance? Okay, so they did a little study, right? They grabbed some freshman psych majors and some freshman business majors, and they're trying to do a little study to figure out who's more likely to change their major. All right. So you know what we're doing here. What do we always do first? Let me go grab the notes with you. The exam 4 notes. Let me grab it. Wherever it may be. There it is. So exam 4 notes. Okay, so here's the exam 4 notes. So I'm going through the details with you. So there's 2 proportions right off the bat. There's everything you need is here in these exam 4 notes. So come up here. There we go. All right, I'll bring that over for us. Let's see, we have that. Yeah, perfect. All right, so I'm going to add that down here for us. And there it is. Okay. So there is our exam 4 notes. Okay, look what it says. So here's the exam 4 notes. It'll help you. Two proportions. That's what we're talking about here. How do we know? Well, it says, well, there's no means. How about that? It never says mean or average, does it? It never says mean or average. So it is proportion. Are you tracking with me? It never says average or mean, so it is proportion. It is proportion. Come on down here. So we know, so it's not means. We'll get to that. We're going to get to that today. If this is proportions, use the 2 prop z test or 2 prop z interval. How do you know which one? Well, this one says test. So it's for a hypothesis test. This one says interval, which we'll do in a minute. So therefore, it's for a confidence interval. Either way, this is what you do for 2 proportions, 2 prop z test or 2 prop z interval. And then notice it says for the hypothesis test, you're going to put HO P1 equals P2, P1's greater or P1's less or not equal to P2. That makes sense? It's saying either, so the HO is always equals, as we know. HO is always equals, that won't change. But now notice we have 2 proportions, not just one. So we're not just saying P equals a number. We're saying P1 equals P2 because we have 2 proportions. We're comparing them. And H1 says P1 is greater, less, or not equal, because that's the opposite of equals, right? One of these is the opposite of equals. Put in the successes, X1 and X2, and total observations in 1 and in 2 for both samples. If given in a percentage, I put a note there, but we don't have a percentage. All right, let's go to it. So I'm going to go on my calculator. Oh, wait, you know what I'm forgetting? What do we always do first on a hypothesis test? We got to write the claim, huh? So let me do that. Let me come up here and write the claim and let that lead us to the HO and the H1. What's being claimed? What's being said here? Freshman psych majors are just as likely to change their majors as business people are. What does that mean, just as likely? Notice it doesn't say more. It doesn't say less.
Would it be equal?
Yeah, it's equals. Does that make sense for everybody? That's P1 equals P2. We'll let the psych majors be P1 and the business majors be population 2. That's just how we do it. The first group is P1, the second group is P2. Yeah, they're claiming that's the phrase, just as likely. They're saying the percentage of psych majors is the same as the percentage of business majors that change their major, just as likely. Not more likely, not less likely, but just as likely, right? If I said, hey, I've got, I know we just finished the World Series. Maybe one team was just as good as the other. What does that phrase mean? Equally good, right? We know that phrase means equal, doesn't it? Just as likely means equally likely. Okay, so then we go on from there. We say, all right, we got that. So what's going to be then? What's going to be our HO and our H1? I'm kind of running out of room to write it. Let me, I'll put it right over here. So what's HO? Remember, HO is always equals, huh? HO is always equal. Now we have the two groups. Now what's H1 going to be? Well, remember, any ideas? How are we going to do H1? It's got to be the opposite of HO, doesn't it? So it's going to be not equal. Everybody with me? Because that's the opposite. And which one is the claim? Is HO the claim or is H1 the claim?
H1.
See what the claim says right here?
HO.
Yeah, see how that's the same as what HO has, huh? Does everybody
Yeah.
see that? See how this and this are exactly the same? So HO must be the claim. Now, all I'm doing is I'm just matching that up. So is everybody with me so far? Remember, one of those two is always the claim. Either HO or H1, one of those two is always the claim. And the HO and the H1 are always different than each other. HO is always equals, just like before with hypothesis tests. HO is always equals. H1, therefore, is the opposite, not equals. And one of those two is the claim. All right, there we go. So we got our HO and H1. On we go. For this study, we should use, and what we're going to use, according to the notes down here, what are we going to use? The 2 prop Z test, right? We good? 2 prop Z test. So we're going to go to our calculator. We're going to use the 2 prop Z test. Is that what it actually says there? I don't know what the options actually are. Let me go back to my.
It is 2 prop Z.
2 prop Z. Is that what it says? Here, let me.
Z test.
Oh, just Z test for a difference between 2 population proportions. Okay, that's what we need right there. Z test for a difference. Okay, it doesn't refer to the calculator. It's just a Z test for the difference. That's what we're trying to test. The difference. The Z test for a difference. All right, we good there. Let's go back to the iPad screen here. Okay, so now the null and alternative. Oh, I guess I could have written them down here, huh? This is going to be P1 equals P2. Is that how they have us selected? I'm gonna have to shift back. I want to see what it's like. So, and then, so yeah, P1 equals P2. That's right. Yeah, good. Okay. I'm just making sure that I'm doing it just like the homework does. Back to the iPad screen again. Okay, yeah, P1 equals P2, and this one is P1 not equal to P2. That's the H1, right? We good there? Everybody make sense of that? And for our own purposes, I'm going to write claim next to HO because that's the one that matches the claim. And what do we always write next to HO? Weak evidence, and H1 requires strong evidence. We're not going to go with H1 unless we get strong evidence. And if the evidence is weak, we're sticking with HO. Just like always, that'll never change. That's how hypothesis tests work. All right, the test statistics. So now it's time to go to our calculator. Let me guide you. It'd be pretty easy. There's really nothing amazing here. I think I'll better add a page just so we have room. Okay, let's go to our calculator. So I'm going to hit stat, go over to tests like usual, and go down. So stat, test, go down to 2 prop Z test, which is number 6. 2 prop Z test, hit enter. It's the one we want. As soon as you do, what'll pop up is X1, N1, X2, N2. All right, and then they have like P1 and they have some various options there. So let's go through the numbers. What's going to be our X1, N1? So remember, N is always, these are totals, right? N is always a total and a total. So, so those are going to be the totals, and X1 and X2 are the amount of those totals. So let's go back. So do you see what those numbers are going to be? So for population 1, for the first group, 346 out of 629 psych majors change their major. So it's 349 over 629. Let me kind of erase this stuff. So that's X1, N1. And then right here, 433, that's X2 and N2. Good, that making sense? X1, N1, X2, N2, because it's what out of what? 346 out of 629 and 433 out of 762. The N's are always the totals, notice. All right, let's go do it. 346, 629. And whatever the other two were for me. 433, 762. Okay, and then what are we going to do down here at the bottom? It wants us to do whatever H1 is that's not equal, huh? Not equal. So we go P1 not equal to P2. Choose that option because that's what we get from H1. It's always exactly whatever H1 has. So there we go. There's the setup, and then hit calculate. And I'll do it also. Let's see what we get here. I'm getting a Z value, which is negative 0.67918. And I'm getting a P value, which is 0.497023. Okay, so that's what I'm getting for my numbers. Let's go back up. So it's asking me right here, my test statistic, that is my Z. Z equals, and how many places? 3 decimal places. So negative point, so I'm getting negative 0.679. And then the P value, and they want 4 places on the P, 0.4970, 49 for me, 0.4970. And the P value is, okay, so you know the deal now. It's just like what it always was for a hypothesis test. Is the P value greater than or less than the alpha level? So we have the P value, right here, 0.4970. And we have the alpha level, which is right here, for me anyway, 0.10. So is my P value greater or less than my alpha?
It's greater.
Greater, right? 49 is way greater than 10. Yeah, greater. So remember the saying that we always use? It's going to be the same saying as always. If the P is low, then null must go. I just encourage you to say that to yourself 10 times a day. You probably have to just get the homework done, huh? If the P is low, then null must go. If the P is low, then null must go. So is our P low or is it not low? At least mine.
It's not low.
Not low. P is not low because it's higher, huh? It's greater. Greater is not low, it's bigger. So P is not low. So HO. So HO does not go, and it means go away, huh? When we say go. So the P is not low, so the HO does not go away. What does that mean? The HO does not go away. We keep HO, don't we? That's what we mean by it doesn't go away. We keep the HO. So I'm going to keep the HO. here's the HO right here. Right there. I'm going to keep it. And that's what I'm believing. I'm crossing out the H1. And I'm keeping HO, which means what do we believe in the end? We believe P1 equals P2, don't we? We believe the freshman and the business major have equal proportions. Same percentage, about. Even though they didn't come out exactly equal, they're not exactly equal, they're so close that we tend to think that really, you know, our sample, this is just a sample, right? This isn't all the business majors and all the psych majors. This is just a sample of both groups. And we're trying to learn something about the truth of all business and psychology majors in the world. And what is our conclusion? Well, based on our sample, because it came out so close, we believe that really psych and business majors change their major before they graduate about the same percentage. We believe it's about equal, which was what was being claimed, equally, just as likely, right? And why? Because evidence was weak, meaning there wasn't strong evidence that they were different. Does that make sense? Let's go down here and read the words. The results are statistically insignificant. Is that true? Were they insignificant? We said weak. Yeah, that's right, huh? You guys with me? If something's insignificant, it's not significant. It's not strong, it's weak. So right away, we can cross off the significant and the significant. It's got to be one of these two that say insignificant, doesn't it? Because the evidence was weak. That's why it's important that you write weak and strong evidence by HO and H1, like I'm always showing you when you do a hypothesis test. Because that'll help you right away figure out which words. You saw that on the exam, that the words really matter. I hope you're seeing that. That's why I'm giving an exam retake opportunity in case that took you off guard. I don't want to surprise you. I tried to say ahead of time the words matter, but I think you really see, especially on that exam, the words are very important. And so make sure you write weak evidence, strong evidence. So yeah, so weak means insignificant. So which one of these is right? Let's go on. So there is a statistically significant evidence to conclude that the population proportion of freshmen who change their major is the same. Well, we do think it's the same, but there's not significant. No, that's the whole point. It's not that. So there is insufficient, yes, to conclude that those who change their major are different. Yeah, there's insufficient to conclude different. There it is. Do you see the difference in what they're saying? It's an important difference. Because you might think, wait a minute, these guys said the right thing. This is what confuses students. Are you guys tracking with me? Watch this closely. These little words really matter. And you can learn these. You just have to spend some time. It's not just the numbers and the button pushing. Really, the most important part of this class is the words. Because in real life, that's what you'll do, right? You'll read and hear statistical studies. You probably won't do many or any on your calculator or anywhere else, but you'll read and hear. So the words are what's most important that I want you to get coming out of this class. See what's wrong here? Here's what students think sometimes. They think, look, it says is the same. So that's my answer, is the same. Mr. Heron, right here, they're equal. That's same. Well, yes, we are concluding same, but the problem is they said statistically significant. No. Why? Evidence is weak. So that's the whole point. The evidence was weak. It wasn't significant. It wasn't strong. You think, well, down here it says different. That can't be right. Well, you got to read the whole sentence. You got to read the whole sentence. It says there's insufficient evidence. There's not enough evidence. There's not enough evidence. There's weak evidence. There's not enough to prove they're different. They're basically saying there's not enough to prove they're different. That's right. That's exactly what happened in this study. There was not enough evidence to prove they were different, that the percentages of psych and business majors changing their major before they graduate was different. There was not enough evidence to prove different. So that's our answer. That's what they're saying, and that's correct. So everybody see that difference? So the weak evidence, strong evidence thing is really important that you write that. It's always weak by the null, strong by the alternative. There we go.